Hello everyone, my name is Naviha and today my friend Devansh and I are going to show you a little magic trick. Or is it a magic trick? Let's see. So for this magic trick, we'll be needing 2 eggs, 3 tablespoons of salt, 1 tablespoon and 2 glasses of water. Let's start by putting 3 tablespoons of salt in 1 glass. And let's well, now let's put 1 egg in a glass of water with no salt. Well, would you look at that? The egg sinks. But now let's put the other egg in the glass with salty water. Whoa, it floats. Now, would you like to know how this magic trick works?
Actually, this is a scientific principle. The egg in the plain water has more density than the plain water, thus it sinks. But the egg in the salty water has less density than the salty water, thus it floats. This is like oil floating on water. The oil floats on water because it has less density than water. It would have more density than water, it would have sunk. Hope you enjoyed our little experiment. We will see you soon. Bye.
Everyone, I am Ayan Gautam from class 6th from the Lawrence School Sanar. I am Shrishti Priya from the Lawrence School Sanar class 6. We are making the working model of Heron's fountain. To make a fountain, we would be needing 3 bottles, a pair of scissors, a glue gun, a screwdriver, some straws and a candle. We have taken 3 straws of similar color and joined them together to make a big straw. Similarly, we have joined 2 straws together to form 3 pieces of straws. Now remove the caps of all 3 bottles. Join both the black caps by using the glue. Use a screwdriver on the flame to make 2 holes on the cap. Take the longest straw, put it through one of the holes in our joint caps. Now we have to put it in the bottle. The straw should be 1 inch above the bottom of the bottle. Now we have to seal both the holes with the glue gun. The blue straw and insert it through the other hole. It should be 3 inches below. Now we have to make a big hole at the bottom of the second bottle. Take the second bottle and let the longest pipe pass through it and tighten the bottle. On the third cap, we have to put 2 more holes. Take the third cap and put it on the bottom of the bottle so that the longest straw passes through it. Now we have to glue it. Take the third straw and pass it through the other hole of the cap. It should be 2 inches above the middle bottle. Now we have to fix the straws at this point and seal the holes using this glue gun. Finally, we cut a funnel from the third bottle and put it here. This is the working model of our Heron's fountain. Now let me show you how it works with a demonstration. Wow, the water has started coming. Yeah, it's so amazing. To make the fountain function again, we have to tilt the bottle so that the water from the lower bottle reaches the middle bottle to make it functional. Okay. Look, it's functioning again. Yeah. Though there were hurdles and many failed attempts. But, like our motto, never give in. We are successful.
Hello everyone, this is Athara Mishra of class 6. Today I and Nadhuvat are going to tell you about water surface tension. What is water surface tension? Relatively high attraction of water molecules to each other through a web of hydrogen bonds. Water has a higher surface tension, 72.8 millinewtons per meter at 20 Celsius than most other liquids. How does water affect the surface of water tension? The water molecules attract one another due to the water's polar property. The hydrogen ends, which are positive in comparison to the negative ends of the oxygen, cause water to stick together. This is why there is surface tension and takes a certain amount of energy to break these intermolecular bonds.
Today we are going to perform an experiment. So what I need for the experiment is 3 coins, 1 play card, an empty glass and a bottle of some water. So let's start the experiment. So I'll first take the empty glass, then I'll place this play card on top of the glass. Now, what will happen if I place 1 coin on it? Let's see. Okay, it fell. Is there any other way that I can balance the coin on the card? Let's try with me pouring some water in the glass. So now I have filled the glass till the top. Now I'll again place the card the same way. Now again I'll put the coin. It didn't fall. Let me try this one as well. Same trick. And again. Okay. Why do you think it happened? Is it magic? No, it is science. The surface tension between water and card holds the card firmly, which is balanced by the weight of coins on the other side. Thank you.
Hello everyone. Myself, Aaron Matthews, Class 6 from Lamatne College, Lucknow. The aim for my experiment is to study the germination of seeds. Germination is the process in which the embryo of a seed becomes active and grows into a baby plant. The conditions necessary for the germination of a seed are water, oxygen, and favorable temperature. The materials required for this experiment are seeds of moong and gram, a bowl with water, a glass, some tissue papers, and cotton. So let's start with the experiment. First, we take the seeds and soak in water for 24 hours. After 24 hours, we see that the seeds swell up and finally the seed coat breaks open. As you can see, then we take a glass and wrap it with some tissue paper, and then we take some seeds and then put it on top of the tissue paper. Then I take some soaked cotton and spread it and cover it over it, as no sunlight is required in this process. After 24 hours, we see the growth of a radicle. A radicle is a part of the seed embryo which develops into root system. When we keep these germinating seeds for a few more days, we can see the following result, as I have kept them in a basket. As we can see, the radicle has grown into the future root system and the premiole has grown into the future shoot system. Therefore, we conclude that the germination of seeds takes place in the presence of water, oxygen, and favorable temperatures. Thank you.
Three, two, one, action!
Hello, this is Zahavi Mehaba from class 6.
And I'm Camelia, and I too study in class 6.
We are most excited to share this experiment with you all today.
An experiment by Heron of Alexandria, a scientist of the 1st century AD.
But why did we choose this project? Well, while we can see just about everything around us, air is something that we cannot.
So we thought, why not an experiment that would help us demonstrate the properties of air in a visual way?
Yes, a sustainable project demonstrating the properties and presence of air any number of times without hurting the environment at all. No requirement of power. It runs on easily available water. Recycled objects used as raw materials.
Okay, now for this experiment, we shall be needing 3 bottles, a few straws, a few bottle caps, a hot glue gun, but you must be careful while using the glue gun so that you don't burn yourself, a pair of scissors, a cutter, and a black marker.
Now, since we need slightly longer straws, we'll join them together with a slight slit in one and then give it another. And then the other straws as well.
First, we need 2 caps and we'll glue them together back to back with the help of a glue gun. So this is what it looks like.
Once done, the 2 bottles can be attached into the cups. We next make a hole at the bottom of the middle, which is going to be inverted. Again, 2 carefully measured out holes on a bottle cap, which is to be glued over the hole on the bottle.
So this is what the structure looks like, and I've inserted the 2 straws, the pink one and the yellow one. The pink one goes right from the top to the bottom and the yellow straw is right in between the 2 bottles. Now we will need to make a funnel-like structure so that it can collect the water from the fountain.
Alright, now that's a Heron's fountain and here we go. We can use this to water plants and also as a decorative piece in our garden. We do hope that you enjoyed our project as much as we did.
Yes, we do. And thank you so much for watching our video.
Good morning everyone. My name is Ratsaran and I am a student of grade 6 at Mayo College Ajmer.
Good morning everyone. My name is Adira Janora and I am a student of grade 6 at Mayo College Ajmer. Today we have constructed a water level indicator with readily available materials at home. To construct this, we have used popsicle sticks, aluminium foil, wires, 9-volt battery and a buzzer for indication.
First we take 3 popsicle sticks, wrap 2 sticks fully with aluminium foil, which will be the conductors as aluminium is a very good conductor, and keep the third stick unwrapped, which will act as an insulator for a water level indicator. Step 2. Now take 2 wires and attach 1 wire to each candy stick and tape the wire and candy sticks together. Step 3. Now tape all 3 candy sticks together and sandwich the insulator or unwrapped candy stick between the 2 conductor sticks or aluminium foil wrapped candy stick. Step 4. Take the 1 wire of the buzzer and connect it with the one wire of the battery connector and tape it. Step 5. Now connect the other wire of the buzzer to one wire of the candlestick wire and tape it. Step 6. And second wire of battery connector to other wire of the candlestick and tape it. Now the circuit of the water level indicator is completed. Now we take an empty container, attach the water level indicator to the container and start filling it with water. Once it touches the desired value of water touches the buzzer, it will turn on and you can turn off the water flow, hence conserving water wastage. As you can hear, the buzzer has gone off as the water has reached its desired level. When we start reducing the water from the container, the buzzer will go off, thereby indicating the low water levels.
Homemade water level indicators have several advantages. Many of the materials being used are cheap and readily available at home.
It helps us to gauge water levels at our own home, be it thereby in large water tanks or small containers or even pots. And it is very low on maintenance.
It helps in controlling wastage of water, which is a big concern around the world today. Conserving water is the need of the hour, and we need to be responsible human beings if we want to save our biggest natural resource.
The scientific principle behind the experiment is conductors and insulators and the completion of circuit. Aluminium foil and water being good conductors which make the current flow and the buzzer gets on. The unwrapped popsicle stick being the insulator acting as a sensor which only turns the buzzer on when the water touches the popsicle sticks and complete the circuit.
Hi Ishita.
Hi Saveer,
Why did you call me?
I am going to show you a magic trick.
A magic trick? You're cracking a joke with me.
Well, no, I'm not. Let's start then.
I am excited to see.
You'll also have to help me out.
Sure.
Here with me are 4 different liquids. This one is strawberry flavored honey. This is water with blue food color. This is saffron soap with green food color. And the last one is olive oil.
But what are you really going to do?
We are going to make a rainbow in a glass.
This truly will be magic. First, we add strawberry flavored honey.
Make sure you add a sufficient amount so that it stands out. Next we add saffron soap.
Then we add water.
Use syringe for this purpose.
Oh,
And for the last layer, we add some olive oil.
wait a few minutes for it to settle down. Whoa, this is extraordinary. But do you think it has happened all by itself?
We have just demonstrated it, but the power of science is behind it.
What is the science in it?
This experiment is based on density. Density is equal to mass by volume. In this experiment, if we take honey and water 250 cubic centimeter each, the volume would be the same, but the mass would be different.
So it is basically that a glass of honey is heavier than a glass of water because it has a higher density.
Yes,
Thanks Ishita for your cool science trick. I really learned a lot today.
same. I also
learned a lot. Thank you.
Thank you.
Dental impression, negative to positive replica.
Hello everyone, I am Sukrit Singh Pukela and Ranchi Nayyar will be doing a science experiment on how dental impressions are made. The materials required for dental impressions are dental trays, dental spatula, dental stone, bowls, water, alginate.
Powder and liquid are mixed to get a homogeneous streak. Alginate is found in the cell walls of brown algae. It is an elastic, irreversible hydrocolloid impression material. As its tear strength is low, it can reproduce the contours and anatomy of the arch very nicely. On mixing alginate powder with water, a chemical reaction takes place and gel is formed. After the tray is loaded with impression material, patient impression is recorded. The tray has to be stabilized in the patient's mouth for 2 to 3 minutes. Pressure will cause the impression to set under strain. On removing the impression from mouth, the strains will be released. The impression has to be removed with a firm quick snap. After disinfecting the impression, it is poured with dental stone. Now water is added to dental stone powder to produce a pourable mix. This mix is carefully poured to cover the impression. Stone mix takes approximately 45 minutes to set completely and to obtain maximum strength. It is carefully separated from the impression and cast is reproduced.
Finally, the negative replica of mouth, that is dental impression, is converted to positive replica, that is dental cast. Dental casts are used for diagnosis, as a record for dental growth and development, visual aid for educating brushing technique, and in sports for athletes in making mouth guards. Thank you.